Good morning, all of you. In today's session, we are going to start with the 10th standard chemistry and physics, where unit number 7, classification of elements, the periodic table, is going to be discussed. In this, we are going to start with series number 1. It is not possible to record the entire unit in the single session. That's why it was made into different fragments. Each segment consists of a certain quantity of the lesson what we are going to discuss, right? So apart from this, earlier we completed unit 1 to 6, entire detailed explanation of all these chapters available on the channel called World of Competitive Chemistry. In addition to that, we entered into this unit 7, classification of elements and the periodic table. Let us go and discuss about series number 1 of this one, periodic properties. Right. So when we go with the introduction, what is the need for this periodic properties and why we have to classify all the elements? So in order to get that, first of all, let us take the example medical shop. When you go to medical shop for any certain medicine, so many medicines are located in that shop. So it is very difficult to locate. So what is your question? You are going to ask for a fever tablet, otherwise a pain relieving agent, whatever you want to do. So within fraction of second, that shop person will bring you whatever you want. In spite of large quantity or large number of various medicines are present, but he able to locate, he able to identify within fraction of seconds whatever you are expecting for. In the similar manner, if you are going to any supermarket, so in that supermarket, all the groceries available, whatever you want, everything is available in that, and moreover all are available in the bulk quantity also, right? So they are arranged in certain way. It is very simple to identify where you are wanting to search for the particular item. So it's very simple and convenient to locate that particular item wherever it is present, because that is available in certain periodical arrangement. In the similar manner, so whenever you go with elements of all the periodic tables, so in order to identify each and every element, in order to remember the properties of each and element, it is very difficult task. In order to avoid that kind of ambiguity, again, just like this medical shop, otherwise this supermarket, we are also arranging our elements in a certain manner, so that you can identify where the element is there and what are its consequent properties. So there is a need for this arrangement of all the elements in the certain periodical manner, so that it is very convenient to identify. It is convenient to study about those elements in the particular kind of what classical way, right? So for that purpose, we need classification of elements. So here we are going to discuss about what is the chronology of periodic properties of elements. Chronology stands for what? How the element classification started and how we are progressing in such a manner, and what is the new version of this periodic properties or classification of element. That entire history of the history of periodic table classification is going to discuss now, where yes, this is the entire classification of properties of all the elements. First discovered element in the chemistry is a phosphorus. So among all the elements in the periodic table, so here so many elements are well known to us. These are entire periodic table elements which are arranged in certain manner. It's very simple to identify the individual properties if it is arranged in this manner, right? So initially identified element, first identified element in the periodic table is a phosphorus by the scientist called Henning Brand, right? Later these are further classified into Boyle. So Roberto Boyle is the next scientist who made a certain classification. At the time of Roberto Boyle, what he felt is this element, whatever element you are taking, for example, you may take hydrogen, you may take oxygen, you may take carbon, whatever. So that kind of element may not be further broken. Breaking of those elements are not possible. Elementary treatise of chemistry. So that is the book was given by this one. And Roberto Boyle used to classify, at the time of Roberto Boyle, 13 elements are well known to us, and those elements are not further broken into any tiny particles. Element itself, it is the tiniest particle. Further breakage of that element may not be possible, right? This is a second generation classification. Move on to third generation classification by Lavoisier. Lavoisier is considered as a father of modern chemistry, who identified oxygen, discovery of oxygen made by this Lavoisier only, and it's a co-scientist Priestley, right? So Elements Transit of Chemistry was the book written by this Lavoisier, and apart from this, so many scientific journal publications also published by the scientist, and so many elements are identified at the time, right? So he is the next person who made the classification for the convenient identification of elements well known at the time, right? So this is a third generation classification, and the next generation classification was made by Johann Wolfgang Dobereiner. Dobereiner identified certain elements are well known at the time. Those elements are made into three sets. Just like in our body also we have DNA. DNA is made up of triplet of amino acids. So there is a three-strand triplet of amino acids are present. In the similar manner, here also he classified elements into triplets. So this is called Dobereiner triads, right? So he made a classification like that, where three elements are made into one set. Those three elements are said to be triad. So this type of classification made by Dobereiner. So only certain elements are made into this category, and we experience some limitations because all the elements not categorized in certain manner, where we can't make into triplets. It is not possible to make all the elements in such a triplet manner. So, but it is the what you can say first, second, third, fourth generation classification made by Dobereiner. Dobereiner triads, three elements are made into one set, just like our DNA made up of three sets of amino acids. In the similar manner, here also three elements are made into a certain group, right? So after this Dobereiner, we have another Newland actives. So Newland classification was given. So just like Newland actives, so what is the use of Newland actives means here? Right. So when you see this Newland classification, what happens? Hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen. In this way, the series will be started. After the oxygen, next coming element will resembles with the first element. This is a kind of system which is purely based on the notes of music. How the music having sa, re, ga, ma, pa, da, ni, again sa will come. That means there is a repetition of the word after certain period. In the similar manner, when we are moving with a certain elements, so repetition of properties are possible in the certain period of time, just like how the musical notations are present, how they are repeating in certain interval. In the similar manner here also, the elements are going to repeat their properties after some interval of time, after certain period of time. These are said to be Newland actives. Newland actives are denoted as 1, 2, 3, 4, 5, 6, 7. After seventh element, eighth element is exactly similar to first element. That's why it is denoted as active. Active is nothing but eighth. Octa denotes what? Eighth element. In the similar manner, first element with eighth element with the 16th with the consequent one. In the similar manner, each time, eighth interval, you will get the similar properties. That denotes what? Hydrogen, fluorine, chlorine, cobalt, all these are having resemblance in their properties. In the similar manner, lithium, sodium, potassium, copper, this is also eighth term repetition. That's why all these are also grouped into certain group, because all are resembling in their properties. Likewise, beryllium, magnesium, calcium, zinc are also having similar kind of properties in their chemical and physical nature. Boron, aluminium, chromium, yttrium. So in this manner, Newland gave the classification purely based on the notes of music. How the same notation is given after the seventh element. After the seventh note, you will get the eighth note as a just like first one. In the similar manner, here also notations are provided. So this is nucleonectives. And next is about Mendeleev. Mendeleev, this is certain kind of scientific classification was started at this time, right? So scientific classification made by Dmitry Mendeleev, where all the elements of periodic table are arranged according to their increasing atomic mass. He considered increasing level of atomic mass for classification of the elements. So atomic weight is considered for the classification of elements, and at the time he assumed there are certain gaps. So at the time all the elements are not well known to us. That's the reason why he framed a certain periodic table where some empty gaps were kept. New elements are going to be invented. Those elements will fit in this. So such a kind of futuristic thought is also there at the time of this Mendeleev, and whatever new element was introduced, that exactly fitting where he left the space. Vacant sites are present. In that site, newly invented elements are exactly fitting. So he gave, after aluminum, he kept one empty space. For that, he assumed as a Eka aluminum. That means next one. Next to aluminum, he gave its name as Eka aluminum. At the time, that element was not known. So later it was invented like a silicon, and it introduced into that region and exactly fitting what the properties Mendeleev expected. Even though element is not known, and he felt that there will be one element and it may contain such a properties. After the invention of in the future, that element exactly fitted here and having resemblance what properties expected by this Mendeleev. That is the futuristic vision of the scientist during the classification of elements, and it is purely based on atomic mass. But we have so many limitations based on this atomic mass classification, so that modern periodic table was framed where all the limitations whatever experienced by all these different historical classifications, all overcome by this modern periodic table, right? So here the elements of all the chemistry and physics are classified according to their electronic configuration. So periodic properties are mainly because of the electronic configuration. You may say atomic number, because atomic number just resembles number of protons or number of electrons, right? Right. So in that manner, this modern periodic table is framed based on the electronic configuration. So electronic configuration is the main cause for the periodic properties of all the elements present in these columns as well as blocks, right? So along with that, you may say all the elements are arranged in accordance with their atomic number rather than atomic mass. Atomic mass is called Mendeleev. Atomic number is called Henry Moseley classification, right? So Henry Moseley classification is most acceptable nowadays. It is the thing we are following, and new elements are added in this manner. There is certain space still. So here, whatever new elements are invented, all are going to be added in certain groups and periods in accordance with their properties. So there is no ambiguity with this modern periodic table. We are very convenient with this kind of classification where electronic configuration plays the major role, because all the chemical properties purely based on the valency electrons present in the given element. So that is the strategy for the classification of all the elements based on various criteria, but finally electronic configuration is the modern periodic table foundation, right? So this is the chronology of the classification starting to till date. So now let us move on to various kind of classifications which are provided by the scientists in accordance with our academic textbook, right? So Roberto Boyle kind of classification, just now we saw here Roberto Boyle classification comes in the second place. Roberto Boyle in 1661 defined all the elements as the substances. Elements are considered as the substances that cannot be decomposed further. Those are the tiniest particles. Further decomposition, further fragmentation may not be possible. And the further simple substance by the physical and chemical change. By applying physical means like a heat, temperature, lowering temperature, otherwise by applying the force by means of any cause, you can't change that. And even by applying with any chemical like acid, base and any oxidizing reducing agent, So by means of physical and chemical means, you are not able to decompose the element. That is the tiniest one, and that will not be transformed into any other kind. So that kind of assumption was provided by the Roberto Boyle in 1669. At this time, about 13 elements are well known. Only 13 elements are known to us because in that 16th century, microscope invention is also not yet done. That's the reason why it's very difficult to classify it. It's difficult to identify. There is a continuous evaluation in the science, right? So that at the time only 13 elements are well known. Now we are experiencing so many elements in our modern periodic table, right? They laid the foundation. We are moving. We are framing all the bricks and that foundation, right? So here Robert Boyle, Irish scientist, discovered that substances are made up of atoms. He called these atoms as an element. Terminology of element was provided by the scientist called Robert Boyle, and the substance made up of only one type of atom. So if you are taking any kind of a substance that is made up of only one type of, for example, I'm taking coal. What it is made up of? It is made up of purely carbon only. Whatever, wherever you are taking and identifying its composition, you can find everywhere carbon only. In such a manner, the substance is made up of only one kind of atoms. He assumed like that, right? And Boyle described the element as a primitive and simple substances. These are the tiniest particles and the simplest particles. So the terminology called element was given by this Robert Boyle. This is close to the modern definition. An element is a substance that cannot be split up to simpler substances by the chemical means. So even now also it is not possible to break one atom into another fragmentation. So unless it is bombarded with a neutron and also like electron, so those are subatomic particles are present, but it is not possible to fragment, and they are not individually isolated. So that is exactly matching with the today's phenomenon also. Predicted that compounds were made up of made from and could be broken down into the elements. Okay, so here substance is the kind of system where only one kind of elements are present, and compound is the system where more than one kind of elements also incorporated in that. These are the kind of blending of all the elements, then compounds are generated. That is the assumption provided by this Robert Boyle. So this will be the ancient one. Now let us move on to second type of classification, which is provided by Anthony Lavoisier. Anthony Lavoisier, considered as the father of modern chemistry towards the end of 18th century. So here Robert Boyle belongs to 16th century and Lavoisier belongs to 18th century. By the time of Lavoisier, another 11 elements are added. 13 are known and more 11 means 24 elements. 24 elements are known to at the time of Anthony Lavoisier. By 1865, about 63 elements are known to us. 1940, total 90 elements, 91 elements are known. Natural source and another 17 elements synthesized in the laboratory. When you observe A block elements, most of the A block elements are artificial means only. So when you go with S block, P block and D block, where last series of elements mostly artificial and radioactive in nature, being as gradually size of the nucleus increases, they are becoming unstable and they are becoming radioactive. They are emitting the radiation, right? So here at the time of Lavoisier, what happens? In total 24 elements are well known. Later 1865, so many scientists worked on that and invented 63 elements, added some more elements there, and there is a gradual evaluation. By 1940, total 91 elements are well known. 91 elements purely from the natural source, from the nature, like wherever different sources like oceanic region, terrestrial region, and also atmosphere. So even in our surrounding region, we can experience so many elements in the air, right? Major quantity will be nitrogen, later oxygen, and carbon dioxide also present. In that manner, in the natural source, so many kind of elements are present. So 91 found in the nature, and more 17 elements synthesized in the laboratory. At the time of Lavoisier, oxygen, nitrogen, hydrogen, phosphorus, mercury, zinc, and sulfur, these elements were added. These are the most important elements which are added at the time of Anthony Lavoisier, why he is regarded as a father of modern chemistry. Lavoisier. Anthony Lavoisier, 1790, compiled list of known elements, and 23 are well known to us. And this is about the classification made by this Anthony Lavoisier. Then existence of a periodic table of elements by now. So when you consider the modern periodic table, total 115 elements are well known. 115th element is regarded as the Moscovium, with atomic number 115 and atomic mass is given by 288. This is the last element. You can't say it is the last because we always we are not able to put the full stop. Always there is a growing research on this. So science will always explore it so that it is the karma only, and you can say as of now we know only 115 element. That 115th element will be Moscovium. So in the scientific, that means a periodic terms, periodic table terminology, that is denoted as UUP, right? So U denotes un, U another un means one. Un is nothing but one, and P is nothing but pentium. Pentium, penta means what? 5. Okay. So here neath 1, eth 2, prop 3, but 4, penta 5. So in this way, UUP, un means 1, P means pentium 5. Un pentium. So this is the periodic table terminology of 115th element. Okay, so in the modern periodic table, the highest number of element is 115. Now, classification of elements. So in the earlier classes, you already learned about the classification based on their metallic properties. Some of the materials may be regarded as metals and some other materials may be non-metals in nature, right? So on which basis metals and non-metals got classified? So here the simplest examples are provided to us. Both belongs to valuable materials in our daily life. One is a gold, that is a metal, and the second is a diamond, which is considered as a non-metal. Here aurum or gold is made up of so mostly metals having the tendency to lose the electrons. Always, whenever you take a sodium, lithium, or aurum, or silver, whatever metal you are taking, all are having the tendency to lose the electrons. By that process, that is turned into a cationic species. But when you consider non-metal, they are having tendency to gain the electrons, electron gaining tendency, so that they are turned into a anionic species. Anion is nothing but negatively charged one. Metallic luster will be there. That means shining surface will be there. Any metal you can take. When you take aluminum, gold, silver, all are having lustrous tendency. Shiny surface will be there. Because of three-dimensional regular arrangement of atoms, they are lustrous in nature, shining in nature. And always non-metals are regarded as a dull, colorless, and some of the materials are exceptionally lustrous. When you take diamond, it is highly lustrous in nature because so many angles will be there. That's the reason why it used to refract the light in so many dimensions. Because of that nature, it having a lustrous tendency. All the metals are regarded as good conductors of electricity, whereas non-metals are poor or non-conductors. You can say insulators. When you take copper rod and what we can say here, we are taking coal, for example. So here copper rod conducts electricity in the nice manner, but coal, it is an insulator, non-conductor of electricity. All metals are very strong in nature, malleable and ductile. Malleable and ductile in the sense you can make into thin sheets and wires. So the thickness, when you take a gold, you may draw into very nanometer size also without any breaking. So in that extent, it will be expanded. So that expansion is called malleability and ductility. Malleable in the sense thin wires, ductility in the sense thin sheets. But when you go with this, when you go with non-metals, when you apply the force, what happened? They completely decomposed. So deformation is possible. That is called a brittle tendency. When you take the plastic box, for example. So if you expand without heating, if you heat, what happened? Because of elasticity, that will be expanded. We are not heating that. Just like that, solid, in the solid nature only you are going to apply the force. Is it expanded? No, just it is a brittle one and easily broken. Deformation is possible. and all the metals are having high melting and boiling point. So in order to convert that solid form into liquid and gaseous form, you have to heat in the furnaces. Separate heating devices are required, which are called kilns or furnaces, where high temperature is provided. Then only they got converted into a liquid state. But when you take plastic, it's very simple to melt that one, and by simple heating, that is turned into a liquid state. So here the melting point of non-metallic substances are extremely low. Most of this are mostly they are solids at room temperature. You may take any metal in the periodic table. Around 80% of the elements in the periodic table are considered as metals only. All the metals are solid in nature, except one metal called mercury. Mercury is the liquid metal. Except mercury, remaining all the metals which are present in the periodic table are regarded as solids in nature, right? Often liquids are gases at room temperature. So you, in case of non-metals, that may be liquids, that may be gaseous in nature. If you take chlorine, that is a gas. Fluorine, it is also gas. Hydrogen, that is also gas. So if you take bromine, that's the liquid non-metal. One and only one liquid non-metal will be the bromine itself. And mostly non-metals are gases only, and even solids also available. You may take coal, diamond, all these are the non-metals, but exist in solid state. That means non-metals may be liquids, solids, gases. Any kind of nature will be adopted by them. But metals are always considered as a solid in nature, because highly regular three-dimensional arrangement will be there in the metals. Exceptionally, only mercury will be the liquid metal. So all metals are sonorous in nature. Sonorous in the sense, again, lusty tendency will be there, and all non-metals are non-sonorous. So this is about the classification already you done in your earlier classes. Metals versus non-metals. Examples for the metals are sodium, potassium. So when sodium, potassium are considered, these are the first group elements in the periodic table. These are called metals. Non-metals examples are sulfur, chlorine are non-metals. Sulfur, chlorine are non-metals in nature. So this is the classification. So if you are going to classify metals and non-metals, it is not completely classified. Complete information is not given. That's why you are facing some limitations with this kind of classification in the periodicity of the elements. Why? Because some of the elements may not be metals, may not be non-metals. You can't categorize them into metals, you can't categorize into non-metal. There is another certain type of materials which are having exceptional properties with respect to these kind of classification. Those are boron, silicon, germanium, arsenic, antimony, and tellurium. These 6 elements which are present in the periodic table, these are having exceptional or distinct properties when compared to metals and non-metals. They are not grouped into metals and non-metals. They are separate category. You say these are metalloids. Metalloids in the sense having partial metallic nature, partial non-metallic nature. Means amphoteric behavior will be there. Means to some extent they are working like a metals. Some extent they are having also non-metallic property. Those are said to be metalloids. Boron, silicon, germanium, arsenic, antimony, tellurium. These 6 elements in the periodic table are regarded as a metalloids. They are having in between properties, neither metals nor non-metals, having transitionary state, right? So these are the boundary line between metals and non-metals. Okay. So element of these types are regarded as metalloids or semi-metals. Semi-metal in the sense partial metallic nature will be there. So this is the limitation with this metal non-metal classification. So we need more accurate classification. So more accurate classification is needed. Now, another classification made by physical and chemical properties. Necessity is the mother of invention, right? So if you need, then it is required to invent something. If it is originally required for us, then we will think about that one, we will work on that one, so that we will achieve that one. In the similar manner, we are, so with this we have certain limitations, so we are moving into another kind of classification of elements based on physical and chemical properties. So purely based on physical and chemical properties, it is possible to categorize all the materials. So modern periodic table purely laying on the chemical properties, that is nothing but electronic configuration. Electronic configuration purely based on its chemical properties only. So this is the right kind of classification what we can say. So physical properties are nothing but by heating, by applying the force, by what we can say by measuring the density. All these comes under physical properties. Chemical properties are nothing but oxidation, reduction, any kind of substitution, addition. All these are the part of chemical kind of properties. So based on this physical and chemical properties also, it is possible to categorize them all elements into various classifications. Now, another scientist who made a next step into the classification of elements, Joseph Louis Proust. Joseph Louis Proust, what he felt is, in the 18th century only, he also made some assumptions. So he purely assumed that hydrogen is the fundamental material. Whatever materials or substances which are available in the universe, all are made up of hydrogens only. So that kind of assumption which is given by this Joseph Louis Proust, what he felt is, Frost said that hydrogen atom is the building material for all kind of elements. So whatever the element you take, some extent hydrogen will be there in that. So that kind of assumption he was made. Okay. So due to simply combination of number of hydrogen atoms, he noted that atomic weights of the elements were given as a whole numbers and atomic weight of hydrogen was taken as 1. So his theory is not exactly scientific one, but one and only one important point what he assumed is, that is exactly right till now also. He assumed that its atomic weight, hydrogen atomic weight, is considered as 1 only when you go with any kind of experimentation. Till now also you will get its atomic weight as a 1 only. That only the correlation with his theory which invented in the 18th century. But his assumption is entirely wrong. It is not possible to locate hydrogen in all the compounds. Some of the compounds made up of hydrogen, some other may not be containing hydrogen as the major quantity, right? But only the thing what he invented, that is exactly following till now also, that one it will be atomic mass of hydrogen, that is 1. This is only the element in the periodic table. Hydrogen only the element in the periodic table having atomic number, atomic mass equal, because it only contains 1 proton. Neutron will not be there. One and only one element having absence of neutron is hydrogen only. That's the reason why atomic number is number of protons. Atomic weight is proton plus neutrons. Here proton is 1, neutron is 0. That's why again atomic mass also 1, right? So that's the reason why here atomic mass, what he assumed is exactly correct. But all the metals, all the substances which ever present in the universe made up of hydrogen is the wrong statement which is given by this Joseph Louis Proust in 18th century. And another, some scientific assumption containing classification started from Dobereiner. So this is the kind of classification which purely based on the triad system. Just now we discussed, he made all the elements into different clusters. Each cluster consists of 3 elements in that. He is the German scientist John Wolfgang Dobereiner in 1829. Again, he belongs to 18th century. Noted that there were a group of elements with the 3 elements. So he made all the elements into different groups. Each group consists of 3 elements. That 3 element system was considered as a triad. So Dobereiner triad. That's why we will say Dobereiner triad. So that Dobereiner triad was having, that triad system is having similar kind of chemical properties. Whatever group is there with the 3 elements, all 3 elements are resembling in their chemical properties. He tried to give a relationship between properties of elements and their atomic weights. He considered elements are purely related with this atomic weight of the element. So that kind of relation he assumed at the time of this Dobereiner 1829. So this is the system called the Dobereiner triad. He prepared 3 Dobereiner triads, the element lithium, sodium, potassium. At the time, these elements are well known. Atomic mass of lithium is 7 around. So you can accurately say 6.9. sodium 23, potassium is 39. And another triad will be calcium, strontium, barium. These three elements are said to be a triad, a bunch of elements. Calcium with the 40.1, strontium with 87.6, barium with 137.3. Chlorine element with 35.5, bromine with 79.9, iodine with 126.9. So these are the atomic weights. Based on their atomic weight, their properties are regulated. So that kind of assumption, that kind of relation was given by this Dobereiner triad. So these a bunch of elements. These three elements are one triad. These three elements of second triad. These three elements of third triad. So this kind of assumption given by Dobereiner law of triads. Okay. So here Dobereiner stated that elements with the similar properties are taken into a triad system and arranged ascending order of their atomic weights. How we arranged? 7 followed by 23 followed by 39.1. Calcium with 40 followed by 87 followed by 37. Chlorine with 35, 79, 120. That means increasing order of atomic weights are given. So arrangement in a certain systematic manner where we are increasing the atomic weight in the regular periodic manner. So all these three elements are having equal properties and increasing atomic weights are arranged in that cluster of elements. Right. Ascending order of atomic weight is considered. Atomic weight of the middle element is the average of the atomic weight of the first and third element. This is an important property which is given by this Dobereiner triad. When you take the average of first and third element, for example, if you take 7, atomic number of lithium as 7, potassium as 40, 7 plus 40, 47, sorry, here 39 is there, 39 plus 7, what we can say, 39 plus 7, it will be 46, by 2, it will become 23. So average of these two is the exact mean of the central metal. So this is a assumption. What he made into triads for each and every triad, it was applicable. It was applicable. That is the important assumption given by this Dobereiner triad. The average of first and third element is exact mean of the central metal, right? So this statistic is called a Dobereiner law of triad. Based on this, here is the problem question was given to you. I'm not going to solve this one. This is the question which is for practice. Can we arrange the following elements in accordance with the Dobereiner triads? Sodium, silicon, chlorine, beryllium, magnesium, calcium. Based on their atomic mass. If atomic mass is known, how can we categorize? You can take first and third element, take the mean of these two, and that should exactly resemble with the central one. If it is so, then you can say these three are said to be a triad system. But sodium is in the cluster of lithium, sodium, potassium. We can't categorize into sodium, silicon, chlorine. I'm giving a hint, but you have to solve this problem based on their atomic weight. The mean or average of first and third element should be the exact mean of the central element. So that is the assumption which is given by Dobereiner triad. This is a question for practice. And this is the activity which is given in your textbook. What is the activity? So different triad systems were provided to us. One is lithium, sodium, potassium. These three elements of one cluster. Lithium with 7, potassium with 39. What we have to do? You have to observe the following table. Elements can each row represent a triad. For this triad, this was given as empty. This arithmetic mean of the atomic weights are given as empty. If you take 7 plus 39, 7 plus 39 by 2, it will be 23. This exactly equals to the sodium. So whatever assumption provided by Dobereiner, exactly mapping with this one, so that it was verified, law was verified. And the calcium was given with 40, strontium to be detected, barium 137. Let us go with average. 40 plus 137 by 2. It will be 88.5, more and equal to 87.5, so that it is also verified. When you go with chlorine, 35.5, iodine 127, 35.5 plus 127 by 2, it will become 81.25, almost resembling the central one, so that it is also verified. When you go with sulfur, selenium and tellurium, sulfur with 32, tellurium with 125, 32 plus 125 by 2, it will become 78.5, exactly mapping with the central one. So that it is also verified. You can say this is also the Dobereiner triad. And one more is chromium, 52. Iron will be with a 56. When you take the average of these two, 52 plus 56 by 2, it will be 54, almost is equal to central manganese. So that all these A, B, C, D, E, all are said to be Dobereiner triads, because the mean of first and third element exactly equals to the central element. So this is the assumption given by Dobereiner triad, where the activity we performed based on the data which is provided in the activity, right? So, Dobereiner triads, what is the conclusion which we drawn from this? In the first row, you will find that atomic weight of the sodium is equal to average of relative of lithium and potassium. So here sodium is exact mean of 7 plus 39 by 2, that will be 23, exactly equals to the central one that we already done in the activity. Then can you establish the same relationship with the set of elements given in the remaining rows? Yes, we already done the calculation. That's why we make it as a done. Find average of all the weights of first and third element in each row and compare with the atomic weight of the middle element. Yes, for all the elements, we took the comparison, and the average was taken and compared with the central element. So that was verified. All are said to be a Dobereiner triads in this. Right. So this was completed by this activity. Now, what is the conclusion for this? Dobereiner attempts gave a clue for atomic weights could be correlated with the properties of elements. So, atomic weight is the main criteria in order to classify the all elements in the periodic table. That is the main assumption provided by this Dobereiner. It made chemists look at the element in terms of group of elements with a similar chemical and physical properties. Whenever new element introduced, that always that scientists having tendency to keep into the different groups. That kind of group assumption was given by this Dobereiner triads. In that way, cluster of elements were made into similar property elements were made into similar group. This eventually led to the rigorous classification of elements and the modern periodic table of the elements. Based on this only, based on this as a foundation, further evaluation of this periodic table was done. So this was very much helpful. So in today's periodic table also, wherever properties are same, there all the elements are grouped into one particular group. So same kind of assumption which is given by this Dobereiner scientist, but with this shorter one, only three elements were taken. Now we expanded into very large number of elements in the modern periodic table. Dobereiner law of triads have facing with certain limitations. All known elements at the time could not be arranged in the form of triads. So here, this is a table. You can say all these are having arithmetic mean exactly equal to central element, so that all are said to be a Dobereiner triads. But apart from this, whatever elements present, they may not match with any certain kind of triads. We are not able to locate all the elements into certain triads. So such kind of classification or into triad system is not possible, not applicable for all the elements which are present, which are invented at that time. The law failed for very low mass and very high mass elements. If the element with moderate, that means in between atomic mass, then it is easily applicable. If you go with hydrogen, otherwise very huge molecule of a block, in that case you are not able to make into certain triad systems. Only moderate element atomic mass will be suitable for making into this triad system. In case of fluorine, chlorine, bromine, atomic weight of chlorine not exactly mean of arithmetic mean of this one, but all these are framed in the same group in a new modern periodic table. Fluorine, chlorine, bromine all belongs to same group. But in accordance with Dobereiner, if you go with the mean of first fluorine and bromine, you can't get the exact mean for the central chlorine. So this is not applicable for this kind of triad system. Being all these placed in the same group, you can't explain based on this triad system. As the technique improved for measuring atomic masses accurately, the law was unable to remain strictly valid. So for all kind of assumptions, in order to explain all the properties, this law is not able to withstand. So that's the reason why we have to move on to the next theory, next advancement in the periodic properties evaluation. Right. So Dobereiner law of triad. What is the relation about elements did Dobereiner wants to establish? What kind of relation he want to establish? I collected this answer from Topper. Thank you. When three elements are taken in the order of their increasing atomic masses, then the average of first and third element is equal to second element. In triad system, first and third element. So when we take the average of these two, in between element mass will be exactly equal. That kind of relation he want to establish, that is given by the Dobereiner triad system. And another question based on this Dobereiner law of triads, the densities of calcium and barium. So here, despite of atomic masses, we are regarding their atomic densities, right? So densities of calcium and barium, 1.55 and 3.51. Why we are taking calcium and barium? Because let us move on to our previous session. Calcium, strontium, barium, these three regarded as a triad given by the Dobereiner. So despite of their atomic masses, we are going to regard their density values. So calcium density will be 1.55 and the barium will be 3.51. What we have to establish? For strontium, we have to establish. How can we? In the similar manner, how we established based on this average of first and third element, in the same manner, here also we can go with this one. I collected this answer from Brainly. Thank you for this. Here, calcium, strontium, barium, these three are regarded as a Dobereiner triads. So it is it used to obey the Dobereiner rule. What is the rule? First to third element mean should be exactly is equal to second element. So by Dobereiner principle, in order to collect the atomic weight of the strontium, atomic weight of calcium plus atomic weight of barium by 2 can be taken. In the same manner, you can expand this equation to even densities. The density of calcium will be 1.55. Density of barium will be 3.51. 1.55 plus 3.51 by 2. When you take the average, what happens? 5.06 by 2, it will be 2.53. That is the exact density of the strontium. Law is verified for this question. Thank you. So by this, we completed Dobereiner triads, and some extent classification was done, and the continuation of this session is going to be discussed in the series number 2. Thank you very much for your consistent listening. I hope this session will be helpful for your preparation. Thank you one and all.